This video is going to be about how we find the upper and lower bounds of calculations, as this is something you struggled with in lesson. So I've given you two numbers here, 340 and 16, which have both been rounded to two significant figures. So first look at 340. The second significant figure is the 40 here. So that's been rounded to the nearest 10. So we halve that, 5, and we add and subtract it to 340 to find our upper and lower bounds. So our lower bound will be 335 and our upper bound will be 345. Likewise with 16, our second significant figure is the 6. That's in the units column. We're now round to the nearest 1. Half of that is 0.5. We add or subtract that to get the upper and lower bounds. So the lower bound will be 15.5 and the upper bound will be 16.5. So if I want the upper bound for 340 add 16, I'll take my biggest possible answer for 340 and my biggest possible answer for 16. So I'll do 340, I'll do 345 add 16.5, and you can work that out. For my lower bound, I'd do the smallest for 340 and add the smallest for 16. Now, when subtracting, if I want the upper bound for 340 minus 16, I want to get the biggest difference between those two numbers that I can. And the way to do that is take the biggest number for 340 and then take away the smallest number for 16. And that would give me the biggest gap. So that would be the upper bound. And then the reverse of that for subtraction. I want to do the smallest number, take away the largest number, and that would give me a lower bound for the subtraction. For multiplication, it would be very similar to addition. I want to take the two bigger numbers and multiply them, and for the lower bound, I want to take the two smaller numbers and multiply them. And then division works very much like subtraction. So to get the largest possible value for the division, I want to divide the largest number for 340 by the smallest number for 15. And to get the lowest possible answer, I want to divide the smallest number for 340 by the largest number for 16. In your exam, they often test this work in context. So I've given you an example here where you're given a force of 2,500 newtons and an area of 20 meters squared. And they might ask you to find the maximum and minimum pressures if both of these numbers have been rounded to, they might say, for example, force has been rounded to two significant figures and area has been rounded to one significant figure. And they say, what are the upper and lower bounds for the pressure? Well, we know that pressure is force divided by area. So the force has been rounded to two significant figures. So that's in the hundreds column. Halve that, 50. So the lowest the force could be would be 2,450 newtons, and the highest possible value would be 2,550 newtons. And if the area is being rounded to one significant figure, that's in the tens column, so we'd halve that. And so the smallest area would be 15 meters squared, and the largest area would be 25 meters squared. So to find the upper bound for the pressure, I can see this as a division. So I've got to take, to find the upper bound, I'll do the largest force, 2,550, and I'll divide that by the smallest area. So 2,550 divided by 15, and that gives me an answer of 170 and the pressure is in newtons per meter squared. And then the lower bound for the pressure will be the smallest possible force divided by the largest possible area. So 2,450 divided by 25 gives me an answer of 98 newtons per meter squared. So I've got my lower bound and my upper bound. Questions for you to do now. First of all, both these numbers have been rounded to 4 significant figures. I want you to find the upper and lower bounds of each of these calculations. And then once you've done that, I would like you to find the maximum and minimum or upper and lower bounds for the mass given this density and this volume.